iPad home, but I forget it in my classroom every day. Oh boy.
I didn't check. You are live on YouTube right now.
Oh.
Do you want me to go put some more water in?
Well, no, there was just, I think there were drips of pure punch on the side.
Is it the point that?
Yeah. Okay. Oh, don't do the ACT help. Just do MATHursday, 9:25.
I was going to do this.
Tutoring.
Stand up.
Do it live. There we go. Math Thursday.
And you are live on YouTube too. So
Lovely. Lovely.
All right, you're being recorded.
Win up to 550,000 diamonds.
What?
Stream Delta Force to collect up to 550,000 diamonds.
So you need to become a gaming.
Sounds like I need to do Delta Force. What is Delta Force?
It's a game about dentists.
I don't think that's true.
Like Call of Duty.
Oh, I don't know if I'd like that. I'm more of a cozy gamer. A little bit of violence. All right, guys, welcome to Math Thursday, where we answer the world's math questions. I'm Sarah. I'm a math teacher here in Michigan, and you can ask me whatever you need help on. So pop your questions in the chat, but for now, we've got a little function notation here. So go ahead, and if you have an answer, put it in the chat, and let's get into it. Welcome, welcome. So we are live here on TikTok and on YouTube. Okay, we've got our first answer guess. Oh, we got our second one. Those are pretty wildly far apart. Okay, hello to everybody on YouTube and on TikTok. Oh my gosh, so many different so many different answers. Okay. Yeah, Peter, I don't think that's the answer, but if you can justify it, go for it. All right, so we got 33, 21, 2, 3, negative 12. Okay. All right. Give you guys another minute to get your answers in. Get your answers locked in, and we'll start getting into it a little bit. Okay. All right, so if you are new here, I go live every Thursday for about an hour at about this time. I have been teaching for a long time, and we mainly focus on pre-algebra through algebra 2, a little bit into pre-calc, but that's beyond that, it's kind of hard to show and work through on this type of forum or platform, but we can. Hi, Edel Nair. Yeah, so this is algebra. This is algebra, but function notation kind of doesn't go away. So if you have questions, if you have subjects that you want to go over, any questions you have, pop them in the chat and we'll see if we can get to it, okay? All right, so this is pretty straightforward with function notation. So the first part of this question is just that function. So what we're saying is that so this here we say is f of x. So when I put x into this function, I would do x squared times 2 plus 5 times x. Now, whatever is in that x spot is what goes into this x. So it's like a substitution thing. Okay, so f of negative 3, what we're going to do is we're just going to substitute in the negative 3 instead of x. Out of room a little bit. That's okay. All right. Okay, so negative 3 squared. Since it's negative 3 in parentheses, I square the negative also, so that becomes positive 9. So this is going to be 2 times 9 plus, 5 times negative 3 is negative 15. So I'm going to say plus minus 15. I know. And then we're going to simplify this a little bit more. So I get 18 minus 15. So f of negative 3 in this case is 3. So it's 3, yep. Yeah, it's not 33, but you would have gotten 33 if you didn't make this a negative 15. So it would have been 18 plus 53, which would have been 33. Or if you had this was still a negative 9, if you put that this was a negative 9, then that would make it negative 18 minus 15. So if you got negative 33, you need to remember that the negative in the negative 3 also is included in that squared. So negative 3 squared becomes 9, positive 9. And if you got positive 33, then 5 times negative 3 is negative 15, not positive 15. There we go. Okay. All right, so function notation, again, whatever's in the parentheses is what you plug into that x, what you substitute in for that x, okay? All right, let's see. So Bryn, what grade math is this? This is, you start seeing this, I'm starting to see it earlier and earlier, which is nice because function notation is something that's really tricky for a lot of kids. So this, you will definitely start seeing it in high school, like 9th grade, like Algebra 1, but more and more pre-algebra teachers are showing it to their students, which I really like, just to get students used to it. And another thing, for those of you teachers who are introducing this, please use letters other than F, because then when you see like G of X, it throws them all off. H of X throws them all off. But you can also, you can substitute in like you can substitute in anything. You could even substitute in like x plus 4 there, and you would have to kind of simplify it through. So it's pretty cool. Hayden, yes, I do teach geometry. RJ Docteur. So proofs are really difficult for me to do in this on this form, like in this setup, because there's so much that you have to write out. So 2-column proofs, ultimately just kind of looking through and just be as nitpicky and detailed as you can be with every single little thing. Use the substitution property. Substitution is going to be your reason for a whole lot of different things. Okay. So proofs are a little bit tough. Proofs are tough to do in this setup. Okay, so I'm sorry we can't do that. Let's see. Harry Potter for life. You hate working with pi. What? Okay, let's see. Okay. All right, let's see. I can't read the name. Piecewise functions. We can certainly talk about piecewise functions. So Hadley, I just kind of talked about proofs. Proofs are they're really difficult for me to get into here, just with the setup that we have. But what I would recommend doing is just reviewing all of your postulates and your theorems and all of that. Hopefully, if your teacher lets you use a list of them, that would be ideal. But that's really kind of the theme, or the thing that you've got. Okay. Let's see. Noelle, do you need help with fractions? So we've got, let's see, Noelle's got this fraction problem, 3/5 plus -10/7. Okay. All right, let's do fractions. Hey, you guys, everybody hates fractions, but it should be a love-hate relationship. Love first. You can hate working with them, but man, they are handy. Makes it really easy to graph stuff. Oh yeah, Harry Potter for life. The fractions are just division. Yeah, that's a huge thing that I have to keep reminding my students of. So after we do this problem, I'll get into piecewise functions because I really like them. And so we'll do a quick little thing about piecewise functions. Okay. Okay. Oh my gosh, Wyatt, is it -6/7? Ugh. I don't think it is. It might be, I don't know. Okay. All right, so when we have a negative fraction, or when we're adding a negative to anything, all right, we can really just change this to minus, right? Because adding a negative is the same thing as subtracting. So when we have these fractions with different denominators, okay, what I'm going to do is you want to change these so they have the same denominator. So you're looking at, I should get into that really cool thing. I saw a TikTok the other day of this teacher that did a really cool demonstration of why fractions work the way that they do. So I'll maybe get into that in just a minute. Okay, so 3/5 minus 10/7. So what we're gonna do is the common denominator here. Yes, you can find the least common multiple, but also the easiest way to do this is to multiply 5 by 7 and you get 35 on the bottom. Okay, now I always just put the 35, I just always put that over there. And then I'm gonna do 7 times 3, which is 21. 5 times 10, which is 50. And it's still gonna be a minus, so 21 minus 50 over 35. 21 minus 50 is 29. So my answer is, and it's gonna be negative 29, right? So it's negative 29 over 35. So that's my answer. Okay. I don't need to simplify that because 29 and 35, there's no common factors. Okay. Okay. All right, so let me start a little list. Okay, so equivalent fractions. Let's see. Oh, piecewise functions. Okay. Okay. How to find MAD? My math has no numbers. Yeah. Yeah, let's see. Okay. Let's see. Well, Rex, I don't know what the real math is because we've been doing math this whole time. All right, and then some integers. Okay. So I'm going to start off with, since we're already on fractions, I'm going to talk about fractions a little bit. Now, with integers, somebody was asking about subtracting integers, and I did kind of mention that when you're working with integers, subtraction is the same thing as adding a negative. So adding a negative is the same thing as subtraction. Okay? So when we're looking at this, if I've got negative 3 minus 5, okay, so negative 3 minus 5, subtraction is the same thing as adding a negative. So negative 3 minus 5 would be negative 3 plus negative 5. So if I have 3 negatives and I add 5 more negatives, I'm going to have 8 negatives, right? So if I have 3 negatives and I add 5 more negatives, I get 8 negatives. Okay, now another way to think about this is, let's see. So another way to think about this is with counters and zero groups. So if I have negative 3, I'm going to do a different one. If I have 4 minus negative 2. Okay, so I'm doing 4 minus negative 2. So I've got 4 positives. 1, 2, 3, 4. And a lot of times when you're first learning about integers, you've got, when you're first learning with integers, you've got a lot of manipulatives and things like that, usually with your teachers. So you'll have like counters or something out on the table. And then if I'm taking away negative 2, if I were just taking away 2, I would just take away those 2, right? But I'm taking away negative 2. So what I would actually do with this is I don't have any negatives to take away. So I can't just add in 2 negatives to take them away because that right there makes it positive 2 overall. But I could add in 2 negatives if I also add in 2 positives because 1 positive and 1 negative makes 0. So these are called 0 pairs, and you can add as many as you need in here for a 0 pair, okay? So then what I can do now is I can take away those two negatives, right? I can take away -2. And if I take away -2, what am I left with? +6. So 4 minus -2 is the same thing as 4 plus 2. So understanding that you've got that negative and negative and they can make a plus, it makes more sense. Like, you know, other than just memorizing that 2 negatives make a positive, like subtracting a negative makes it addition, this is why, right? So this is where you're actually learning the why behind it. Okay, so minus a negative makes it a positive, makes it addition. Okay, so again, you can kind of go through with these, like, I like doing it with these like two-sided counters, and you can always add in zero groups to take away things. But with integers, it just takes so much practice. Okay. All right. Oh, I didn't actually mean to erase that. Oh well. Okay, so piecewise functions. Oh, that's from a nice little quadratic thing that we had before. Okay, so a piecewise function. A function in general is where you've got, you know, usually you first start dealing with functions as linear equations. Okay, so that's when you first see them typically. Okay. So a piecewise function is a function that's in a bunch of little pieces. I've said it a million times and I'll say it a million more times, but like mathematicians, we are not terribly creative with naming things, right? Slope intercept form, it's the slope and the intercept. Point slope form, it's the slope and a point. Piecewise functions, it's a function that's in pieces. That's it. Okay, so the piecewise function is where we have a function f of x. Actually, you know what? I'm going to call it something different. I'm not going to call it f of x. I'm going to call it h of x. Okay? H of x, this function is in pieces. So the first piece is that h of x is 2x minus 2, but only when x is less than 0. H of x is -1, but only when x is greater than or equal to 0 and less than 3. And let's do purple for this one. Okay. And then the last one is that h of x is -4x plus 16 when x is greater than or equal to 3. Okay, so we've got these 3 different pieces. Okay, we got these 3 different pieces. So I've got 3 different sections of what this function is going to look like. Okay. A lot of times when you're looking at real life data and stuff, it's not going to be this nice, clean, perfect line of, you know, correlation and all of that. Sometimes it is, but it's not always. So sometimes you have to write these piecewise functions to map motion or something like that, right? A lot of like when you're programming, like a robot's movement, right? You don't want it to just go in a straight line. You might want it to go for this. Like I worked with our first robotics team for a while. And when you have that autonomous portion, right, there'd be like one section where you have to program the robot to do all this stuff without you controlling it at all. So you would have to go through and you would have to program and think ahead and think through all these different situations for it to do what you want it to do when you're not controlling it. So piecewise functions are just made of all these different like pieces, okay? A function made of pieces. Look at that. Okay. So now we're going to graph these. Now what I'm going to do is I'm going to mark this graph so it's a little bit easier to see. I should be able... 1, 2, 3, 4, 5. I think I should be able to fit this all on here. So I'm going to just kind of make these so like each one of these, like 2 of these boxes is going to be 1. Okay, just so you guys can see this a little bit easier. Okay. All right, so there we go. All right, so our first part of the function, I like to do this. I like to just kind of, we're obviously working in pencil, right? So 2x minus 2. So I'm going to go back to my linear equation days, right? 2x minus 2. So I'm going to start at -2 because that's my y-intercept, right? And then my slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. I'm going to go down here, down 2 over 1, right? And it would keep going. Okay. Now, this is only if x is less than 0. So I'm actually only going to graph this in this direction. Okay. And I'm going to change this to an open circle because when x is less than 0, when x is less than 0, it's following this line. Boop. Okay. Let's look at the next one. When x is greater than or equal to 0 and less than 3, it's just x equals, oh, I'm sorry, h of x equals -1. So that means that h of x is -1 is right here. And it's just going to go until 3. So 1, 2, 3. So when x is between 0 and 3, it's following that line. Okay. And then my last bit is, I'm going to move this down here. When x is greater than or equal to 3, I've got 4x plus 16, or sorry, -4x plus 16. So I don't have 16 on my graph, but I know I have a slope of -4, right? So I'm going to find one of my points, which is going to be if x is 3, then y would be, let's see, -4 times 3 is -12. Plus 16 is 4. So at 3, 4, 1, 2, 3, 4, there. And I know it's a slope of -4, so I'm going to go down 4, 1, 2, 3, 4, over 1. There's my line. 1, 2, 3, 4, over 1. Okay, so now this, I'm going to do my best to draw this line. That is my piecewise function. So again, piecewise functions are where it's still a function, right? I don't have any overlap. Whatever x value I plug in, I know what I'm going to get for my y value, right? So this is still a function, but it's in pieces. Okay, so this is what a piecewise function is going to look like. Sometimes they can be quadratic, sometimes they can be exponential, absolute value. There's all sorts of things that they can be, but ultimately it's just a function that's in pieces. Okay? All right, so that is piecewise functions. All right, so I know the chat has been kind of blowing up. Okay. All right, so guys, remember, we're not really doing calculus in here. We kind of stop at about like a little bit of pre-calc, but mainly algebra 2 and pre-algebra to algebra 2 is sort of our main focus in here. But if you have a question, please put it in the chat because we have a great community here and people will jump in and help you with any questions you might have. Okay. All right, so let's see. Please explain graphing a polynomial function. Okay, so Quincy, let's see. All right. Okay, let's see. Quincy, you've got graphing polynomial functions. Quincy, can you give me an example of a polynomial function that you're talking about? Are you talking about like a quadratic? Or do you mean like higher degrees or what? Penny, how to solve equations with complex numbers. That's still left over from last week. Lindsay, it's gonna be really hard for me to go over basic geometry honors like in 20 minutes. So you can pick one thing and I can go over one thing, but I can't really do everything for geometry honors. But you'll catch up. If you're getting transferred in, you're gonna catch up. You're gonna be great. Okay, let's see. Okay, so quadratic, Quincy, let's see. Okay, so graphing a quadratic. Okay. All right, so graphing a quadratic function. So graphing quadratic functions, graphing any function or graphing anything ultimately boils down to you can always just make a t-chart. You can always just make an x and y chart. Okay, that will work for any function that you have. X, Y, plug it in, you can get a good idea. Now, it may have you kind of miss some of the little turns when you get into more like higher degree of polynomials, but overall, you can get a good idea of just doing X and Y. Okay, so let's see. All right, so when we have a quadratic function, so what a quadratic function really means, like what is it, right? So we've got, when you're looking at quadratic functions, we'll do f of x equals ax squared plus bx plus c. Okay, that's the basic form, that's the standard form of a quadratic equation. Okay, now there can be lots of different things that are kind of happening within that quadratic equation. It might be a little bit different, it might be a little bit the same, all of that kind of stuff. But ultimately, what you are looking for is you've got this, you're looking for that x squared. So if that power is the squared, it's going to look like just a curve. It's going to look something like this. Okay, it's going to open up if the a is positive, and it's going to open down if the a is negative. Okay, so that's what we're looking for. So anytime that there's the squared, it's going to be positive and negative. Okay, so you can certainly change it to vertex form if you're ready for, for completing the square and things like that. But you can also figure out the vertex without putting it into vertex form. Okay, so what we'll do is let's do this one. Okay. So if we have a function, we'll do, I don't know, k of x. I'm going to mix up these letters just to keep everybody on their toes. Is negative x squared minus 2x plus 3. Okay. So when we look at this, negative x squared, that means it's going to open down. Okay, it's going to open down. Now this right here, when we think about slope-intercept form, right? The number that's by itself is always the y-intercept. Still true. That's the y-intercept. Okay, now that doesn't mean that that's where our turn is. That doesn't mean that's where our vertex is, right? So this point that's right here, that's in the bottom or in the top, that's called the vertex. Here it would be a minimum because it's like everything's greater than that. Here it would be a maximum because everything's less than that. Okay, so what you want to figure out when you're graphing these is you've got to figure out the vertex. And then through that vertex, there's something called the axis of symmetry. Okay, and it's just like a folding line. Okay, the parabola is completely mirrored right over that, that axis of symmetry. Okay. So our big thing with this is figuring out the negative b over 2a. Okay. So negative b over 2a refers to these coefficients. So our b is negative 2 and our a is negative 1. So in this case, negative b over 2a is positive 2 over negative 2, right? Because negative 2 is 2, and 2 times negative 1 is negative 2. So our negative b over 2a is negative 1. So negative 1 is where our axis of symmetry is. It's right at x equals negative 1. Ooh, this is a crispy dry erase marker. I like it. Okay, so that's going to be our mirror line. We know a couple things about this now. The axis of symmetry is that folding line. So our vertex is somewhere along this line. So now what I need to figure out is where along this line is my vertex. So I'm going to use this and plug it in here. I'm going to find k of negative 1. So when x is negative 1, what is my y value? So negative 1 squared minus 2 times negative 1 plus 3. So negative 1 squared is 1, but negative 1 is negative 1 plus 2. So we've got negative 2 times negative 1, which is positive 2, and then plus 3. So negative 1 plus 2 is 1. 1 plus 3 is 4. So that means that my vertex is at negative 1, 4. Okay. So now that I know where my axis of symmetry is, and I know that my vertex is along that axis of symmetry at negative 1, 4. So negative 1, 1, 2, 3, 4 here. Okay. Now from here, what I can do is I can just, again, remember what I said, what always works for functions, just plugging in points and figuring out where they are, right? So I'm going to go ahead and I'm going to pick a couple of values of x, depending on what your teacher says, how many points you need to pick. But I'm going to look here. I'm going to pick points on the side that are close to the axis of symmetry. So I'm going to go with like x equals 0, which we already know is the y-intercept, right? And x equals 1, and maybe x equals 2 if I can fit it in there, okay? So I'm going to make my little t-chart over here. So I want to figure out when x is 0, and when x is 1, and when x is 2. Now when x is 0, negative 0 squared is 0, minus 0 plus 3, so y is 3. So that point's going to go right there. Okay. Yep. Is it Asia? I can't read. I think it's Asia. Yep. So whatever, if I find 1 point, remember it's a folding, right? I found another point. It's right there. And plug in negative 2. It's great. Okay, now 1. So I've got negative 1 minus 2, which is negative 3, plus 3, which is 0. Right? So that means at 1, the y is 0. And then I mirror it over here. And then let's see how far down number 2 is. So negative 2 squared, so that's negative 4. Minus 4, so that's negative 8, plus 3 is negative 5. So here it's going to be negative 5. So 1, 2, 3, 4, 5 is right here. And that's right there. So now I have enough points to do my nice curve. Okay. And I tell my students, like, just give it a semblance of a curve just so it doesn't look like a V shape, right? Because that's an absolute value equation. Now, when you're solving a quadratic, okay, when you're solving a quadratic, these are what you're looking for. These are called the zeros. They're also called the x-intercepts. They are also called the roots. Okay, so when you're using the quadratic equation, or you're solving by factoring, or you're solving by completing the square, and you come up with these numbers, that's what you're trying to find. Okay, so that's what you're trying to find when you are looking for those zeros. So there's lots of different ways to figure that out. You can do it by graphing for a lot of them. You can use the quadratic formula, you can complete the square, you can do all sorts of things that you have been taught to figure out. Okay, Lindsay, you've been very patient with honors geometry. Okay, so you're switching into honors geometry as a freshman. That's exciting. Congratulations. So honors geometry, you know, let's pull the chat. What would you guys say? I know a lot of you have already been through geometry. Okay, and what would you all say is the most important thing to remember about geometry? And don't say proofs, because proofs, don't get me started on proofs. Proofs are just a logical argument. I think a lot of people get a little bit hung up on the 2-paragraph proofs, especially in high school. Like, you need to justify your thinking, but do you have to write a formal 2-paragraph or 2-column proof? I'm of the school of thought that you don't really need to do that in high school geometry, but I may be in the minority. I don't know. Let me know. Geometry is not the worst thing ever. Okay. Postulates and theories. Yeah. See, but here's the thing, is that if you took out the proofs from geometry, what would it be as bad? Okay, the proofs are the part that everybody struggles with the most, I think. Right? So without the proofs, it's not so bad. Lindsay, maybe you'll have a teacher that doesn't emphasize proofs so much. So see, John Arbuckle saying geometry can't exist without proofs. I disagree with that, because I think geometry can exist without formal proof writing. You still need to justify. I'm not saying you don't need to justify and string things together. I'm saying writing out a formal 2-column proof causes everybody to hate geometry. So why do we do it? We don't have to do it. Take a proof writing class. Okay? Yeah, see, nobody remembers anything except for proofs. Okay, so the biggest thing, Lindsay, is, first of all, don't be scared of proofs. It's fine. Okay, anytime that you learned a number property or anything like that, and it says, like, substitution, addition, property of equality, those types of things. So proofs are where you are writing down specific reasons for each thing. Okay, there are lots of formulas. But being able to justify and link things together and think about something logically, okay? So let me give you an example. If I've got this diagram, right? Here we got this point. We'll say A, B, C, D. Okay. And I'm going to say that AC is a line. Okay. So what that means is that angle ABD plus angle DBC equals 180. So if I told you that this angle here is 4x plus 10, okay, and this angle here is, I don't know, x plus 30. Sure, we'll go with that. Okay. What we can do, okay? Oh, art of problem solving. Oh, I love art of problem solving. Those are really good. So the AOPS is the art of problem solving for geometry. Yeah, I love doing the art of problem solving. I really like that stuff. It is. So Lindsay, algebra is so comfortable for everybody. So as soon as you can basically, it's a lot of it is sort of like translating it into algebra, because as soon as you go from this and you go, oh, so they just add together to equal 180. So then you go, okay, so 4x plus 10 plus x plus 30 is 180. So 5x plus 40 is 180. So 5x is 140. So x is 28. There you go. So this one is 58 degrees, right? And this one would be 122. Yeah, 122 degrees. 122. Yeah. That's geometry. Okay, that's a big part of geometry, I should say. Now, the proof piece is where you have to explain, or not even really explain, but justify how you know this is true, right? So what you would need to say, well, because this is all in degrees, all right? So this is all in degrees, that x is 28, so 28 plus 30 is 58 degrees. 4 times 28 plus 10 is 122 degrees. Yeah, so it's just plugging it back in. Okay. So proofs are fine. You'll get through them. Okay. Don't let that color your whole opinion about geometry, because when you get into like algebra 2 and pre-calc and more advanced maths, geometry and algebra are not separated as much. So we at my school actually don't teach a separate geometry course. We teach geometry, algebra 1 and algebra 2, kind of all over the course of 2 years. So that's just kind of something to keep in mind. But so what you would need to do is, the first thing that you would do in your proof is state that like these two are supplementary angles. And then you have to say, so they add up to 180 degrees, right? You have to think about all the background knowledge that goes into how you can set this up to be true. Okay, so that's where a proof comes in, and you're using like theories and laws and all that kind of stuff. Okay. All right. Okay, so I wanted to show you guys this one sort of trick. Ooh, but you know what? I need to review it again. I don't want to do it and do it wrong. So, all right. So let's do, yeah, Lindsay, it's just an explanation. It's just, and so like I said, I have my students justify and explain. You can do a paragraph proof, which I'm much more on board with paragraph proofs than the 2-column proofs, because 2-column proofs are very like stuffy and like specific things. I have students like write paragraphs and things to explain how they know different parts when we're deep into geometry. Yes, so I only do this on Thursdays for about an hour. So we're kind of coming up on the tail end of the hour. But let's do some factoring polynomials. Okay, so we'll do solving by factoring. Okay, so let's do, well, let's just start with factoring. Okay, so we'll factor, okay, so we're going to factor 2x squared plus x minus 3. Yep, Lindsay, anytime you want to come back. I love factoring, which is why I end up doing it every week. As soon as anybody asks for factoring, I'm like, yes, let's do it. We're factoring. But man, I remember having such a hard time doing trig when I was in high school. And then it finally clicked. So those of you in the chat, let me know what was your least favorite section of math? What was your least favorite thing to learn about in math, or the thing that you just couldn't get over? Oh no, Kylie, factoring was the worst thing? Oh boy. Well, welcome. I love factoring. Oh, calc lost you. Interesting. Like I said, I had a really hard time up until pre-calc. And then once I kind of got over the pre-calc hump, like I took 3 more years of calculus and I was relatively fine. But yeah, pre-calc, it took me a while to really start thinking about trig. And then once I realized how like straightforward trig was, it was pretty nice. Oh, proofs, yeah. Oh, let me see. Jen, teach 2-step equations to solve for X. My 10th grade SPED students are struggling. Okay. So here's what I would do. Okay, so Jen, this is just for you. So guys, we'll come back to the factoring in just a minute. So so I would start with everything, like nothing is a fraction, nothing is negative, right? So just starting with very, very simple, straightforward. So they can, what I tell my students all the time is we practice and do it right while it's easy. So we're ready when it gets more complicated because the pattern doesn't change. So if I have 2x plus 5 equals 9, right? So if I have something like this, when I have students who are really struggling with this, because it's something that they really struggle with, right? So what I do is, and I've tried doing like you do the inverse operation, you know, reverse, oh my God, order of operations. Geez Louise, it's been a long day. But what I found to be the best was for them to do where you cover this up. You say, okay, I don't know what X is, but what plus 5 equals 9? Okay, and we can say, well, I know 4 plus 5 equals 9, but then you can also talk about fact families with that. So if even what plus 5 equals 9 is a little tricky for them, I don't know what what tier your students are, what you're working with, then you can say, okay, well, what is 9 minus 5? Well, that's going to be 4, right? If I take away this 5 and I take away this 5 here, and I'm left with 4. So now 2x has to be 4. So then I have 4 plus 5 is 9. So working that way, and then we talk about like 2 times what is 4. So just working a lot on their like number fluency and number sense and things like that. And like I said, keep it with really nice, clean numbers. And, depending on your students, you might be able to throw in some division and things like that. But again, like just doing this, just kind of like solving the mystery, I've had a lot of really good success with that. So hopefully it works for you with your kids. Okay. All right, let's see. Yeah, covering just focus on one thing at a time, right? Because then you can do 2 times what is 4. And then again, you can get into fact families, right? Well, like 2 times what is 4? Well, then 4 divided by 2 is 2. So doing like the little fact families and all that kind of stuff is really nice. This makes it a much more approachable. And also I would highly recommend, Jen, still talking to you, would highly recommend the Key series. It's from the Key, Key, Key Curriculum Press. The Key to Algebra, Key to Pre-Algebra, Key to all sorts of things. They're really nice, clean, so easy to read, great workbooks, and pretty inexpensive. And you know, buy one or make copies of it. You're not supposed to do that, but I mean, yeah, so that is a really, really, really good useful thing. Yeah, I think it's Key Curriculum Press. They might be through I don't know. They're designed for more like homeschooling, I think, but I've used them in school for a while with some of my students who are just really struggling. So John, I teach mainly it's like algebra 2. Yeah. So sophomores, 10th graders, and some 11th graders, which are going into pre-calc, kind of bridging between algebra 2 and pre-calc. But I've taught, 6th grade through pre-calc really. But I was a science teacher before. So I taught, like biochemistry, biology, chemistry, all that good stuff. Okay. Factoring. I don't do the X method. I do factoring by grouping or the AC method. Usually I'm teaching this after we've just done factoring by grouping. So it's really nice and easy. It's a nice, easy way to get into that. So when you're factoring, if this first value has if this first term has a coefficient other than 1, the first thing you need to do is, this is why it's called the AC method, which is A times C. So that's -6. So what I'm looking for is 2. Oh man, Vivid, AP Bio. Yes, I taught AP Bio for quite a few years. Okay, so -6. So we want to find 2 numbers that multiply to -6 and add to +1 because that's what's in the middle. Okay, so since this is -6, so I think about all the factors. Whoa. I think about all the factors of 6. So 1 and 6 and 2 and 3. All right, now 1 and 6, there's no way that I can play around with a positive and negative to get a +1, right? But 2 and 3, I can play around with a positive and negative to add those together to get +1. So I'm going to have +3 and -2. Because -2 times +3 gives me -6. And -2 plus 3 gives me +1. Okay, so now I split the middle. I'm going to rewrite this +1x as -2x plus 3x, because that's the same thing as +1x. And then I bring down my -3 and I bring down my 2x squared. So at this point, I'm factoring by grouping. So factoring by grouping is when you have 4 terms and you kind of split it in half and you take out the greatest common factor for each of those groups of 2. Okay, so I'm going to group, I've got 2x squared minus 2x. So the greatest common factor there is 2x. All right. And when I take that 2x out, I'm left with 2x times x minus 1. Okay, because I take out 2x squared divided by 2x is x. -2x divided by 2x is -1. Then I go over here and I have +3x minus 3. My greatest common factor there is a +3. If this sign here is negative, you have to factor out a -2. There's some little nuances with this, but we're just kind of doing a pretty basic example. So then I've got +3, and whatever's left behind is x minus 1. Now I can keep going with my factoring because look, just like up here, we took out the greatest common factor, right? Here, we've got a common factor too. These are both divisible by x minus 1. So if I take out the x minus 1, what's left behind is 2x plus 3. And if I multiply those back together, okay, if I multiply these back together, I have x times 2x, which is 2x squared. I have x times 3, which is plus 3x. Minus 1 times 2x, which is minus 2x. So 3x minus 2x is 1x. And then -1 times 3 is -3. Ta-da! Right? So then you can multiply these together to get back to your trinomial. Okay, and just double check. Okay. Tucker, some suggestions to self-study some algebra to tighten my skills. There are so many resources that are out there, including there is a free math curriculum that I really like, which is called Eureka Math. And it's free. You can get it on, well, I think they might have changed it to like Eureka Squared or Cubed Math. I don't know. But they do have free PDFs online that you can just look at the different modules and you can download it. And they have practice problems and they have all sorts of things. And I like a lot of their problems. Some of the problems get really complex, which is kind of nice sometimes. But yeah, there's lots of like free curriculum, or you can also just go online and just order a used Algebra 1 textbook. They're all over the place, right? Okay. All right. So, my friends, it's been a long day. It's been a long week. It's Spirit Week at school, so it's been an especially long week. Have a wonderful night and keep doing math. And I will see you guys. I will be back again next Thursday. So if you guys have any questions in the meantime, or you want some one-on-one tutoring or anything like that, click the link in my bio and you can set up an appointment. And I will see you guys next week. Bye.
Then if you go to the StreamYard, OBS, that one, and then stop streaming.